All right, hello, welcome. If you're watching this on Twitch, this is my first ever live programming stream. If you're watching this as a video, I originally live streamed this on Twitch, what you're going to see today, and I'm hoping to edit it down into a more reasonable video, which I'll then post to YouTube and send out on my Substack. So today, the goal is going to be to provision a database for my project fearless.tools. That's kind of one of the critical infrastructure pieces you're going to need to build a website that has any sort of state with it. Maybe you want to just have users log in and store data for the users. Just really anything other than a static web page, you're going to need a database eventually. So we're going to mostly be covering the provisioning of this database using infrastructure as code. I'm going to be using Pulumi because that's what I've been explaining how to use in my blog posts, and that's what I use in my project. You could easily do the same thing with a tool like Terraform, and it would look very similar to what I do today. We are running in AWS, so we're going to be provisioning our infrastructure there. The service for databases in AWS that we're going to be using is called RDS. It has a few different types of databases. We're going to provision a Postgres database. We want to use a SQL database just kind of because it's the de facto standard. A lot of people like to use NoSQL databases like MongoDB. I like to just use a SQL database whenever I can, unless I know for some reason that I really need a NoSQL database. You can do JSON in Postgres as well, so you can still kind of do schema-less things in Postgres, and the performance is actually still on par with Mongo, or even better sometimes, even when you're doing JSON inside of Postgres. So we're going to dive into it. I have VS Code open here. This is my actual code for the fearless.tools website, and I'm going to go into this infrastructure folder, which is where I store all of my infrastructure as code. You can see that I've kind of divided it up by the type of service that I'm provisioning. So I've got some AWS budget stuff, I have my IAM permissions, I actually have some policies code, which I've talked about in a previous blog post. And then I have my Route 53 DNS infrastructure. So I'm going to create a new folder here. We'll call it RDS. And then I'm going to kind of copy just the file structure from another one of these folders. So the first file we're going to want is this pulumi.yaml. This is the top level file for Pulumi projects. It just has a couple variables that we care about. Runtime, we're using Node.js. And the name we're going to change here to RDS. Just realized I should probably increase the font a bit. Okay, I think that'll be good. Maybe even slightly excessive, but I'd rather have it be too big than too small. Then next, we're going to copy this pulumi.main.yaml file over. And most of this we're just going to, actually all of this we're just going to leave the same. This is basically just telling the Pulumi project how to access AWS. We have a default region, and we have a IAM role that we've already provisioned that we want Pulumi to assume before it tries to provision infrastructure. The skip credentials validation is, I believe, just a weird little bug with Pulumi, if I remember correctly. It doesn't really matter a whole lot. It doesn't really mean too much. And then finally, we're going to just copy over an index.ts. This is just our main actual code entry point. And we're going to delete everything almost. And what we're left with is the beginning. We're importing a couple of things. We're importing the Pulumi package and the AWS Pulumi package. And then we're defining some default tags for our resources. So next we want to start figuring out what does the resource that we want to provision look like. And so there's a couple of places that you could start when you're trying to figure this out. You might be looking directly at the AWS documentation to sort of see what the documentation for their services are. Another place you might go is to the Pulumi documentation. So they have a website. I can't remember the name of it off the top of my head, so we'll navigate there. It's this registry. And this is basically a documentation of all of the Pulumi packages that exist and the resources that they provision. So we're using this AWS Classic one right now. So we'll click on that, and then API docs. And then the modules here basically correspond to all of the individual services that AWS offers. So we're going to search for RDS. And then there's a good amount of things here still. And it's not necessarily clear which one to use initially. So we're going to actually go to the RDS documentation and start perusing through that. So this webpage talks about RDS and Aurora. If you're not familiar with AWS or RDS specifically in AWS, you probably won't know what this means. RDS is their sort of classic databases where you have actual servers that are running the database, and you might have multiple of those servers, and you have to have a primary and secondary that is replicated to, and you kind of have to configure all of that yourself somewhat. Aurora is sort of their like more bespoke version of this. And in particular, they have a version called Aurora Serverless, where you don't actually have to consider individual servers. You can configure it and just get an endpoint without worrying about the size of the nodes or how many nodes, setting up replication, all of those things. And just have an endpoint that you can use as a Postgres database. And one of the cool things is it can even scale to 0. So if you have a project like mine that's generally not being accessed, and you want a database for it, but you don't want to pay for it to be always running, Aurora Serverless could be a good choice, because when no one's actually accessing your website or interacting with it at all, that database can spin down to 0 and hopefully then not cost you as much money. And so that's what we're actually going to use. So let's take a look at the Aurora user guide. So it mentions fully managed. You have a choice between MySQL and Postgres. We're going to use Postgres just because, for one, I'm more familiar with it. 2, I believe it's a bit more open source than MySQL. I couldn't explain to you the details of that, and I could be wrong potentially, but it's just kind of the more accepted choice, I would say. So what I mentioned before was maybe slightly wrong. Aurora does also have the versions where you have to set up clusters of nodes, but it does also then have that serverless version, and so that's what we're going to look into. So let's see if, let's go here, using Aurora Serverless v2. Getting started. Maybe creating a cluster. So we know that it's called a cluster. So let's maybe see if this cluster resource here will actually let us provision an Aurora Serverless cluster. This looks promising. Aurora with Postgres engine. There's also this example that says RDS Serverless v2. Let's try this one. So we already have these imports. Let's copy the rest of this code. And let's start changing some of these parameters. So we're just going to change the name of it in Pulumi to fearless.tools. We'll use the same thing for the cluster identifier. We're going to leave the engine as Aurora Postgres. Engine mode provisioned. That sounds okay for now. Database name, we'll change to Postgres. Actually, sorry, we'll change that to Fearless. Master username, we'll also make Fearless. And the master password, we're just going to create some sort of random string for now. I think later I'll go over the process to actually securely generate a password for this and when you provision it. For now though, I'm just going to consider this kind of temporary. I'll probably spin it up and spin it back down a few times, so we'll just put some characters there. Serverless v2 scaling configuration. Don't really know exactly what that is yet, so we'll just leave it as is. We're going to delete this variable identifier because we're not going to reference it at the moment. And then cluster instance. We'll change this to fearless.tools as well. So it's unhappy with this engine parameter. I think because the types where it's being output as a string and this expects this enum. What this code was doing here was just referencing the value from the cluster so that we didn't have to specify the same string again twice. For now, let's just repeat ourselves. Ideally, we want to keep things dry as much as possible, but let's just do that for the moment. All right, so now that we have some code here, also one last thing, let's actually use the tags that we specified, just so that when things are provisioned, they have some lineage on them. We can tell that the resource was created by Pulumi when we look at it later. Do that for both of those. Okay, now we're going to open up a terminal. We're going to navigate to where this Pulumi project exists. Go to the RDS folder. And we should see the, oh, we do not yet actually see the stack that we created here. So let's just try running a Pulumi preview. All right, we have to create the stack manually. So we will do Pulumi stack. I can't remember the command, so we'll do a help. Init is what we want, so we'll do Pulumi stack init. We just want to call this main because that's what we titled it when we created this pulumi.main.yaml folder or file. There we go. Now if we do a Pulumi stack ls, we'll see it, and we'll see it selected, so we can run a preview. I'm using a tool called AWS Vault to store my actual AWS credentials, and it's protected by a password that I have to enter. And so this gets automatically invoked when I try to use it. Okay, so we have an issue. Only lowercase alphanumeric characters and hyphens allowed in cluster identifier. So the issue is probably our dot that we put here, so let's just call it fearless instead. Run that again. I should probably make the font here bigger as well. Okay, so we have our preview. We see that we're creating a new stack, which is RDS, which was the name of our project, dash, and then main was the name of our stack. And we're creating two resources. So we have an RDS cluster and an RDS cluster instance. That seems reasonable. Let's just go ahead and apply that. All right, so that failed because we do not have permission to do so on the role that we are assuming. So I mentioned before that we're assuming this role that we've created for the purposes of provisioning infrastructure, and it seems that that does not actually have the permissions that we need. So let's go take a look at where we're defining that. In our IAM folder index, here is the role, the infrastructure role we were talking about. And then let's find the actual policy for that. It's much harder to look to code when it's this large and I can't see that much of it. Okay. So here's where we're attaching some role policies to that infrastructure role. So we're giving it IAM access. We're giving it some access to the AWS budgets. Interestingly, it seems we're giving it system admin access, which I thought was basically allow it to do anything, but it's still failing. So I'm going to open up the AWS console so we can take a look at some things. Okay, so here's our AWS console. We're going to navigate to IAM. Then roles, infrastructure, which is the role we've been talking about. And let's take a look at this system administrator role. So this is actually not a full admin role, which kind of explains why it wasn't working like we maybe expected it to. And you'll notice if we look at RDS, the permissions that it has are actually read-only permissions. I don't know exactly how they decided on these permissions. This is kind of a built-in role that they have come up with called a system administrator. And for whatever reason, they decided that this job function does not need those permissions. So what we're going to do is look through some of the other built-in policies and find one that gives us more access to RDS. So we have this Amazon RDS full access, which basically gives you anything you would need to interact with RDS. And we're going to use that as a new role policy attachment on our infrastructure role. So we create this new role policy attachment resource. We'll call it infrastructure RDS. And then that name that we saw here, this Amazon RDS full access, that is the name of the policy that we need to grab. So we're using this get policy output function to grab this existing policy that exists. And then we're referencing its ARN Amazon resource name and using that as the input to the policy ARN for this role policy attachment. So we'll save that, go back to our terminal. go to the IAM folder. And now we'll do a preview of that stack. All right, so we see it's going to add a new role policy attachment. That looks good. So let's go ahead and apply it with a Pulumi up. Oops, accidentally hit no. Okay, and don't worry, this password has been changed. This output is not going to help you get into anything. I could probably remove that initial password output from the code, but I'll do that at some point. So we've created this new role policy attachment. So our infrastructure role should have more permissions now. Let's go back to RDS and try to apply that again. Okay, we haven't gotten an error right away, so it seems like it's working. RDS operations tend to be kind of slow in general. Creating RDS clusters can take a little while, unfortunately, sometimes minutes. But let's maybe go take a look at RDS in the console and see if we see our cluster spinning up. Make sure we're in the right region, of course, too. When we were doing IAM resources, it didn't matter since those are global, but for RDS, you have resources in each region. We saw before that our default is US West 2, so we'll switch to there. All right, so we see things spinning up. So these are the two resources that we created. So we have the cluster itself, and then we have a serverless instance on it. Even though this is serverless, it still kind of calls it an instance. But creating that instance is what takes a little while. But I believe we can already go in here and start taking a look at some of this information. So we have a couple endpoints to access this RDS cluster. We have a normal one, and we also have a read-only endpoint. So the read-only endpoint can generally scale more easily, but of course you can't do any operations that need to modify your database. And it also may have a little bit of replication lag. So if you need the absolute latest data, you could run into issues if you're using that endpoint in certain places in your code. So we can grab these from the console, of course, but let's also take a look at how we can grab these in code so that we might use them elsewhere. So while that continues to finish provisioning, we'll go back to our code here, rds/index.ts. And then let's create an output. So for an example of that, why don't we go look at that initial password one that we grabbed. Copy paste that here. Oops. Okay, so we'll say export const endpoint is equal to. So we have this variable where we've stored the cluster. Let's just call this cluster instead. And so it's going to be cluster dot, and then our autocomplete here is showing us some outputs of it, of course. And it looks like there's one called endpoint, which is what we want. So let's just do that. and we need to fix these other couple of references that we had that we're still using. Example cluster is the name. Okay. Still waiting on this, hopefully not too much longer. Drink some coffee while we wait. You're not a real infrastructure engineer until you complain about waiting for RDS operations, and it only takes one time before you want to complain about it. So do it once and you're a real infrastructure engineer. And if you're ever worried that something is going wrong with the process here, you're wondering why is this still creating after 5 minutes, the console is nice to reassure you that it is actually still creating. If we refresh this page, we see that the AWS console still shows it in creating as well. This is just kind of slow, unfortunately, and we have to wait. One thing interesting, you'll notice that this instance identifier is what looks like this auto-generated text. That is because we did not provide our own identifier parameter here, and so the underlying code auto-generated it. That's fine, we could have also provided a value, and you'll notice it's actually prefixed with TF for Terraform, and that's because the Pulumi classic provider actually uses Terraform under the hood. Any day now. Just waiting. We'll refresh this again just to help our sanity. AWS thinks it's still creating. Lost a viewer, they got tired of waiting. I don't blame them. I'm also tired of waiting. I think these serverless instances take even longer than the normal ones. This has just been quite the wait. If this actually ends up taking too long, at some point Pulumi will kind of just give up waiting. I think there's a built-in timeout on this of maybe 10 minutes, so we could be coming up on it quite shortly. It won't hurt anything. Pulumi will just sort of stop waiting for it, and then the cluster will continue to create in AWS. And once it's actually finished creating, we can just run this again, and it'll see that it's finished creating, and everything will be happy. Looks like it wasn't at 10 minutes, but we'll see what happens. Oh, we've changed to configuring enhanced monitoring. That's a good step. Let's see, I wonder if that means that Pulumi thinks it's finished. No, it still is waiting for it to actually reach the created state, or the available state, I suppose. But hopefully that means we're close. One more refresh, just to make ourselves feel better. Available, great. And here we go, this finished. So last thing we're gonna do is we're gonna run this one more time to take a look at the output that we just set. There we go. So we don't even actually have to run it because it's already in the state. We see this output that's going to be created, which is the endpoint for accessing the database. You would need to also add a port to this. That port is defaulted because we didn't set it, but we could have also provided a non-default option if we wanted to with this port parameter. If we look in the console, oops, too many tabbing. Where we go? Yeah, so here we go, 5432, which is the default Postgres port. You could also grab that as an output from the code as well if you wanted to, so that you could programmatically interpolate the endpoint and the port. Why don't we do that actually, instead of just the cluster.endpoint. So we're going to use a couple variables here. We're going to use the cluster.endpoint and then colon. Watching me try to type out this has got to be painful. And the cluster.port. So now we're doing a single string that has both the endpoint and the port of the cluster. We'll run this again. And we get this crazy thing. So calling toString on an output is not supported. Anytime you see this, the issue is basically that you have done string interpolation on something that Pulumi considers an output. And these variables are outputs, cluster.endpoint and cluster.port. And so if you try to just put them in a string, it tries to call toString on them, and that just doesn't work. And so it's really easy to fix. Instead of just doing the normal string interpolation, you'll do pulumi.interpolate in front of it, and it should work. So let's try one more time. There we go. So now we have this nice string that already has the domain and the port in the endpoint. And we could even get a little fancier if we wanted to. We could start doing things like putting the Postgres :/ that you sometimes have to provide for a Postgres connection string. But for now, we'll just leave this as is. And we've created a Postgres cluster, a serverless Amazon Aurora Postgres cluster using infrastructure as code in about 30 lines of code. We're outputting the endpoint, so potentially we could have some other infrastructure as code that actually provisions some service that we've created that is going to connect to that database. And yeah, that's it. That's all I'm going to cover today. It's a short. Feel free to leave any questions that you have.